Okay, so we're moving on to series. And this is going to be arithmetic series, and then the next one we'll get to geometric series. Basically, the only difference between a sequence and a series is that in a series you're adding all the terms in the sequence. So it's the sum of the terms in the sequence, which is why instead of commas between each term, you have addition signs between each term. Okay? So this is a series, and you're finding the sum of the series 12 plus 9 plus 26 plus, and you don't know how many terms there are in between here, and this last term is 180. So the terms in this sequence, the n still represents the number of terms, except in this case it's number of terms being added. The a1 is still the first term. A sub n is the last term in the sequence, and S sub n is the sum of all the terms in that sequence or series. So for this one, what I know is I know 12 is A sub 1, the first term. I know A sub n is 180. I don't know what term number 180 is. I don't know what term number 180 is. So if there's any part of this that you don't know that you need, you're going to use the AN formula. Because I want to find out what term number 180 is, I'm going to plug that 180 in for AN. The A1 is 12. I'm trying to find the N for that 180. And I do know the common difference, which is 7, because it's 12 plus 7 is 19, plus 7 is 26, and so forth. And so now you're just simplifying. So 180 equals 12 plus 7n minus 7. 7n plus 5 when you combine the 12 and the negative 7. And 175 divided by 7 becomes 25. So that gives me enough information now to use the SN formula or the sum formula in order to find the sum of all those terms, because now I have the n. So what this tells me is that I'm trying to find the sum of the first 25 terms in this sequence, because 180 is the 25th term. So n is equal to 25, and to find the sum of the 25 terms, I have n, which is 25, times 12 plus 180 divided by 2. Let me simplify. 92 divided by 2 becomes 96, and 96 times 25 becomes 2,400, or 2,400. So that is the sum of all the terms in that sequence. So in this one, it's asking to find the first 3 terms of the arithmetic series. So they gave me A1, they gave me A sub n, and they gave me S sub n. So they gave me the sum. They gave me the first term and the last term. So what I'm going to do is I'm going to try to find n. I'm plugging this in the SN formula, which I have here. I don't know the n. I know A1 is 7. I know AN is 79. And I'm only missing that n here, which I can solve for. So I have 430 equals n times 86 divided by 2. Well, 86 divided by 2 becomes 43. Divide by 43 and n is equal to 10. Well, the next thing I need to know is the common difference. I still don't know the common difference. Okay, so use what you have. So in the first one, I had the sum, so I used the sum formula. Well, I need to find the common difference. I know the first term. I don't know how to find this next term. I do know now that the 10th term is 79. So what I can use is the AN formula, and I know AN is 79, A1 is 7, plus I know the N is 10, 10 minus 1 is 9, and now I'm just solving this. So I subtract 7, 72 is equal to 9 times D, divide by 9, and D is equal to 8. So this is going to be 7, add 8 to it is 15, add 8 to that becomes 23. So these are the first 3 terms. Okay, so here's another way to ask for the sum of a series. It's called sigma notation, and it uses the Greek letter sigma. You may also hear this as summation notation, which is kind of cooler to say, summation notation. But what it is this value on top of the sigma, that's E is the sigma, and that value is the last value of the series. This is the first one. Now, when it's talking about that, it's talking about the term number, the n basically. So what term number it starts with and what term number it ends with, and you're finding the sum of all of the ones in between. So this one is referring to the sum of this series that has this equation from the first term to the 12th term. Okay, so here I want to find the sum from the 4th term to the 18th term. So in order to find the sum of all those terms, I need to find what that first term in the series is, what the last term in the series is, and I need to know how many terms there are. Well, this can get a little confusing because this A1 is referring to the first term that's with your series that you're adding. So it's not plugging in 1 for the equation. That would give you the first term from the sequence. But in this case, I want to start with the 4th term. So this is really going to be A sub 4 from that equation. So I'm going to plug in 4. And so when I plug in 4, 6 times 4 is 24. 24 minus 1 is 23. The last term, I'm going to plug in 18. 6 times 18 is 108, minus 1 is 107. And the n. Well, to find the n, how many terms are from the 4th term to the 18th term? A lot of people, you're going to realize, oh, I just subtracted 2. Yes, except you're including that 4th term, so it means that you have to add 1 back. Okay, I'll explain that a little more in depth right now, but basically to find your n, you subtract these 2 and add 1 back. And so it's going to be 18 minus 4 is 14, plus 1 is 15. So now I can plug it into that formula. So I'm going to scroll up a little bit, and I have 23 plus 107, the 3 gets me to 110, plus 20 more is 130, divided by 2 is 65. 15 times 65 becomes 975. So the sum from the 4th term to the 18th term for the series that uses this equation is going to be 975. All right, so this is the last example, and it's to write it in summation notation for this series. So in order to do so, what I need is I need to know, I'm always going to, when I'm writing it, I'm going to start with the first term. So 7 is the first term. What else do I know about this series? I know the common difference is 4, and I know the last term is 207, but I don't know what term number that is. Okay, so in order to do so, I need to find the equation, which I'm going to use the AN formula, which I have all the stuff to do that. I'm plugging in 7, and I end up getting 4n plus 3. So in order to write it in summation notation, I have to find the equation for that series or for that sequence. And I put that here in this spot next to the sigma. I'm starting with the first term to the nth term. It's not 207. I need to find what term number 207 is. So in order to do that, I can use the AN formula as well. And since I've already solved everything, I'm just going to plug it into this formula. I know the last term is 207. I'm trying to find the n for that term. So solve for n. Plug it in here to the equation. Plug it in on the left side. Subtract 3. 204 equals 4n. Divide by 4. 51 is equal to n. So it means that 207 is the 51st term, and that's what I'm trying to find the sum up to, is the 51st term. And that's how you write the sigma notation for a series.
All right. So what's a sea monster's favorite meal? Fish and chips! Instead of fish and chips. Fish and chips!